Hello, everyone. Thank you for joining us for our Olympus Automated Weld Inspection Seminar today. I have Brandon Reitz from Houston who's going to be running this presentation. A couple housekeeping things before we get started. If you'd like to say anything in the chat, there's a chat bar on the side screen here. And at the bottom of the screen, you can ask a question which we can address throughout the presentation and as well at the end. Right now, I'll pass it over to Brandon.
Thanks, Graham. Good morning, everyone. As Graham said, my name is Brandon Reitz. I'm a senior applications engineer with Olympus, based out of Houston, Texas. I'm going on about 2 years with Olympus and a little over 8 years of advanced UT field experience. Today, we're going to discuss Olympus's automated weld inspection solution with the SteerROVER scanner and the OmniScan X3. The SteerROVER is an automated scanner that can be utilized for both weld inspection and corrosion. Today we're going to be focusing on the weld inspection side. We're going to get started with a brief video demonstrating some of the SteerROVER's capabilities, as well as collecting data on a plate sample with the X3. I'll go into the scan plan on the X3, show you the setup, and we'll get into some of the analysis of the weld data. So let me share my screen and we'll get started with the short video. See, the SteerROVER, obviously by the name, has steering capabilities, so you can inspect one weld and transfer it over to another, or in cases where maybe scaffolding will not be required, and you can utilize the steering capabilities to get the scanner in position to start your scan. This is going to be the data and setup we're going to go over today on the X3 and in the PC-based analysis softwares. All right. So I'm going to pull up my X3 here. I'll show you our scan plan, kind of go over the basics of that data file we collected. So I'll go to my main menu, plan and calibrate, and scan plan. So first tab here, we've got our part and weld. We are inspecting a mild steel part, so it'll pull the velocities for that. It is a plate, which is 0.875 inches thick, around 22 millimeters. It is a single V, so we've got our single V selected in our weld template. And we've got it configured to the actual bevel configuration. Onto our probe and wedges tab. We are running two A32 probes, 5 megahertz, on a N55S wedge, as well as a set of TOF probes. These are 70-degree wedges. I believe these are going to be a 5 megahertz. Yep, these are going to be 5. So moving on to our groups tab. This is where we configure our focal laws, whether we're running maybe a sectoral, linear, configure our TOF PCS, focus distance, as well as index and scan offsets. So just a quick overview of our scan plan here. We have some 3D features. These can also be screenshotted and inserted into a procedure or report or anything along the lines of that. This is our 3D view. We can go to a top view. So this kind of gives us a representation of our offsets within our scanner. And some of the groups are running. So we've got a 90 and 270 skew. And we are also running our coupling check channels. So built into the X3 scan plan, we can utilize our coupling check channels. What this does is it steers a 0-degree focal law, and it uses a gate to monitor the backwall signal. So if depending, like if we're using our Axiom scanner, which is in a presentation later this afternoon, it has a coupling check light on the scanner itself. So we can utilize that to not constantly monitor the instrument screen and focus on actually getting that scan. In this case, it's going to collect a coupling check group. So say you send it off to a level 3 or a third-party review, there's going to be data there showing that good coupling was held throughout the entire scan, as well as our TOF group there. So that's our basic scan plan. We'll pull up this data in Omni PC. So transferring the files to a USB or SD card and then importing it onto a PC. We can open up that data file into our free viewer, which is Omni PC. It's included free with the X3, no software key or license required. Anybody can actually download this from our website and utilize this with X3 data files. So you can see our C-scan, our B-scan for our TOF, as well as our 270 SKU C-scan here. And on the left, or the right-hand side of the C-scan and the left on the 270, you can see our coupling check. So if I pull up a different view here, you can also see our coupling checks in the middle of our C-scan. So this indicates that we had good coupling throughout our scan. And you can see on our A scan, if we select that group, we're just monitoring a backwall, just like a conventional 0-degree probe, single element. So if I just pull some gain out, just to show you for an example, gray, complete loss of coupling. And you can see kind of like an intermittent loss of coupling, but this is just due to adjustment of that gain. So we know we had good coupling throughout this entire scan. With an Omni PC, just a basic analysis tool, we do have the abilities to adjust our gates, gain, do some flaw sizing, just lacking some of the advanced features that we're going to go over in our Weld site software after we get through this. So we'll just go grab a flaw for an example. We can adjust our gates to clean up that C-scan, so we're really just monitoring that flaw. I'll do the same in our 270 SKU. All right, and just some little shortcuts here. We've got our, if we hold control, we can click and drag and zoom in on a flaw. We can set our data cursor on the flaw and utilize the auto 80 function. And do the same on our 270. All right. So let's just do a quick length size on our 270 SKU here. So I've got it set to 80%, so we'll just do a quick 6 dB length size drop sizing. So I'm going to utilize the color palette. So by touching on the color palette in the A-scan, I'm going to change my start to 40%. And utilizing my cursors, a shift left is a shortcut for the reference cursor, and a shift right for the measure. So by adjusting the color palette, anything that is not white essentially is going to be 40% or higher, so it'll give us our 6 dB drop. We can do the same for a height size. So in this case, we actually, it's a ID notch, so we'll just do a tip diffraction technique. So I'll do a shift left on the center of our tip and a shift right at our corner trap. And utilizing our measurement panes here, I can change our readouts to automated weld. Now we can see we're at 80% screen height. Our depth to that corner trap is right at about 21.8 millimeters. Our length size, which would be our scan axis, measure minus reference, giving us the measurement between these two cursors, is 32 millimeters in length, and our height measured from our reference and measure cursor in our S-scan, it's the ultrasound axis, measure minus reference, so we've got a height of about 5 millimeters. We're going to use our zoom out tool. So if we were happy with that, we wanted to add that to our indication table. We can open up our indication table. We'll get a screenshot of that flaw that we have peeked up and all the same readouts that we just went over in our measurement panes. We can accept or reject these indications. We can, type in some notes as well as classify this. And then this can be exported to a CSV Excel file as well as the images, so it can be imported into a report. Open up my color palette back up. So we can have a quick look at our TOF group. So we can select our group here, select TOF. We're going to select a single view layout. So our TOF is currently uncalibrated. We've got our reference cursor. You can see that our first negative signal on our lateral way is at 13 microseconds. So we'll pull a clean area with no flaws, and we can just do a quick calibration. So we're going to do a wedge delay and PCS calibration. Target 1 is 0, so our reference cursor on our negative peak. And we'll set our reference cursor on our first positive on the back wall, sorry. And you can see we're at 13.9 and 15.8 once we hit calibrate. Now we have our time base calibrated 0 and 22.2. So then we can go through and process our data, do any sort of height sizing. But for the most part, that's the basics of OmniPC. It's definitely capable of doing some basic analysis tools. There's not much more than you need for basic analysis. It can definitely take care of that. WeldSight, though, is our successor to TomoView. It is a software that does require a license. But there's some great features in there for speeding up analysis and just diving in a little bit further. So let me hop over to our WeldSight program. So user interface here is a little bit different, but very easy to catch on for an OmniPC or OmniScan user. All our measurement readouts here are the exact same, so a nice easy transition there. I'm going to select a different layout. So let's have a look at a 2PA. It's got an A scan in the middle, and these are actually volume corrected C scans. So unlike a typical amplitude-based C scan like in OmniPC or as you see here, you can see our index axis is actually based on our focal law. Whereas in a volume corrected, it shows our true position based on our index position, right? So we've got our 0 or weld center line. You can see our guides for our weld toes and our negative and positive side of the weld. So much easier for locating flaws and kind of looking through the data and really understanding what we're looking at, right? We've got some consistent signals here, going to be likely some geometry. As we scroll through, we can see it's just some far side root geometry. And as we go into just our amplitude base, right, you can see it's not in a true position, so a little bit harder to understand exactly where those indications are popping up at. Another nice thing about WeldSight is we have the ability to customize layouts as it fits the user. So just right-clicking on a display, we can do a quick split, select our Layouts tab, and we can just drag and drop displays. So if we wanted to add a B-scan, we can do that. Select our 270 SKU, and we can add a B-scan down here as well. I'm going to go over to just a B-scan display, so a 2PA ASB. Nice thing here is we can turn on our tracking feature. So as we scroll through this data, it'll actually snap to the highest amplitude peak in our S-scan, so we don't have to constantly adjust those cursors to repopulate our B-scan. Another nice deal is our data cursor linking. So currently enabled, but we have our link data cursor option, so we can actually scroll through one S-scan and visualize both B-scans changing simultaneously. I'm going to enable my reference and measure cursor. So by setting it on the weld zone or the area of interest we're looking at, we can scroll through. I'm actually going to pull up a different view here. We can move our cursors through our data. Say we're interested in taking a look at this flaw here. We can utilize our snap to peak, and it'll automatically pull that peak with our data cursor in our S-scan. And it does respect which view we're in. So we can do the same in our 270 SKU. We can drag our cursors over to that flaw there, snap to peak, and we're going to snap on that as well. Just like in OmniPC, we do have the abilities to do a quick auto 80. That's on a shortcut here on the left side. Tap that. And now we've got our auto 80 in our 90 SKU, and we can auto 80 that same flaw in our 270 SKU. So just scrolling through the data, same processing of the gates. We can utilize our gates to gate out some of this geometry and scroll through that data for quick analysis. But a really big thing to some of the advanced users is going to be merging. So talking data merging here. So merging a 270 SKU and a 90 SKU, so we can visualize both of those simultaneously. So if I select our merge analysis and merge tab, we have a few options here. So I'm doing a 1mm merge resolution, projection. I'm going to select just my 270 and 90. We're going to disregard our coupling check channels currently and select merge. So now, by utilizing our cursors, we have a few different ways to manipulate the data. We've got our top view, or our C-scan, a side view, similar to a V-scan, and then a D-scan, which is essentially our two sectorals merged together. But by utilizing cursors, we can scroll through that data on multiple axes and just do, scroll through quickly, really identify flaws, and then we typically go back to an unmerged view to do some sizing. It'll be a bit more accurate that way. But just, you finish a scan, open up a data file, and you can do some really quick analysis and get a general idea if that's a good or bad weld within a merge view. We also can manipulate the cursors in other views here. If we wanted to just take a look at this, one of these flaws. So our D-scan view here is going to actually show everything that's within these two black cursors. So instead of looking at a single data point, like it would look something along the lines of this, we can actually look at the full length of that flaw within a C-scan, or within our D-scan. So that's really nice, especially if we're talking like a crack, right? Instead of looking at a single data point, we can look at a full projection of the full length of that crack. Let's see what. So another good thing. So let's say, for an example, maybe you only have one probe and wedge, and you want to do a dual-sided weld inspection, or maybe just your scanner is only capable of housing a single probe and wedge. WeldSet can be used to actually merge files instead of just merging the data. So I'll give you an example of that. We'll go to our setup and open. I've got two scans here, 90 and 270, in two separate data files. So if I just control and click, the file merge will automatically be checked, and I can select open. So instead of viewing those two separately, now we can grab a display that houses two groups, and we can look at both of those simultaneously. And I'm going to merge that, and I'll show you some of our modeling tools. So this is good for showing off to, it could be to your customers for reporting. we run a merge on our two groups, also when we're doing piping, we have this polar view when we're talking merging. Polar view is good for doing a correction, a length size correction based on curvature. That's where that's going to help you out. But if we go to the modeling tab, with our part correctly defined on the X31 Helix's data file, we actually have a nice 3D model on a pipe of that data. So we can visualize where those flaws are, how it's oriented in the part in reference to 0. And this can be, screenshotted, exported into a report. So I'm going to go back and show you some of the Toft functions that we have within WeldSite. Go open up that same data file we just had open. Going to select my Toft display. Just pull a little gain out of that. So just like in OmniPC, we did a wedge delay PCS calibration. We'll do the same here. So if I go to Analysis, Toft, I'm going to select my target 2 to our wall thickness, which is 22.22. I'm going to set my reference and measure cursor. First negative on our lateral wave, first positive on our back wall. And then I'll run our wedge delay calibration. So just like on the PC, now we got our 0 set on our lateral, our 22 on our back wall, and then we can start doing our sizing. Another nice thing would be a lateral wave synchronization, so a straightening tool. So what we'll do is we'll select our LWSR, or our lateral wave synchronization. We can turn on our gate, which will show us what the straightening is going to affect. I'm going to select a different trigger here. We'll go first peak and activate. So before I activate, if you just visualize this red line here, now nice and straight across. So if you have like a little probe rock or a little uneven surface condition, it's pretty common to have that lateral wave a little bit bumpy. So instead of calibrating each point when you're trying to evaluate a flaw, we can just utilize our straightening tool, and we'll get a nice depth location on all of our flaws across the whole scan. So that's about it on our WeldSite side. There's a bunch of great features in here: customizable displays, merging, modeling, some things that aren't available in OmniPC. But definitely a great tool to have in your toolbox for the weld inspection side. That about wraps up what I've got here. Does anybody have any questions? You can either throw it in the chat or the Ask Questions button on the bottom of the page there. Could be specific to scanners, the instrumentation, software, maybe even an application-specific question. Give those a minute to roll through, see if anybody's got any questions, and then we can wrap it up.
Just while we wait there, just a reminder to everybody, you can go back and watch this seminar again through the Crowdcast page. It does look like we have one question that has popped up here, Brandon. What's the difference between your Weld Rover and the SteerROVER?
Sure, yeah, so the Weld Rover is actually, just by the name anyway, is not a steerable scanner. So it's a single axis scanner. So you set it on, you can select, here I'll actually pull it up just to give us a visualization here, make it a little easier. So actually our Weld Rover is right here. So just a single axis scanner. We've got our remote controller. You either go forward or backwards. You set a speed, and you can run that scan. You have to manually stop the scanner, and there's no option for steering or, whether the weld's not perfectly straight. With the SteerROVER, we can manually steer it around as the scanner goes around our part. Also, like you saw in the video, we can drive that scanner down the part in another direction. The Weld Rover as well is designed for just circ welds. The SteerROVER is capable of circ welds as well as axial welds.
Does anyone else have any questions they'd like to ask while we have Brandon here? Here's one. What's the difference between using the Weld Rover versus a pipe wizard?
Yeah, so the pipe wizard is a track system. So if you're talking, doing production pipeline scanning, sometimes the Weld Rover is utilized because it can actually be used on a welding track. So if it's like an automated weld process done in some pipeline applications, the Weld Rover it's a much larger instrument, not as portable as something like the SteerROVER or a Weld Rover, but it runs on a track. So it can be run on the welding track and utilizes fixed probe positions and can scan that pipeline. But it's really more for the pipeline application and not really like an oil and gas or just in general pipe tank vessel inspections.
Here's another question for you, Brandon. Do the automated scanners utilize lasers to guide the travel? Will it work on wide weld caps like a 3-inch thick weld?
So there's a laser option as far as just a manual guide, right? So when you set up the scanner, you'll set the laser on either maybe the center line or a toe of a weld, and you can utilize that just to help you steer that scanner along. Let's see if I have a picture of one here. But as far as like an automated tracking system, that's an option that's actually available for the SteerROVER. So it will find the weld and it'll automatically track that scanner. But the typical solution would be to utilize just a typical, like a red or green laser that we sell that adapts to the SteerROVER, and then you manually steer that to keep that scanner straight and along that weld axis.
And then the second part of that question was will it work on wide weld caps like that of a 3-inch thick weld?
Yeah, so that would be probably on the auto tracker system. I'm not 100% sure on the width off the top of my head. That's something that I'll have to dive into a little bit further. But if you get with your local rep, we can definitely get that question answered for you and figure out what's the max width we can go on a cap for the auto tracking.
Thank you. I do not see any other questions at the moment here. If you do have any other questions after we've signed off, feel free to reach out to your local representative and we'd be happy to get you the technical support and information that you require. Otherwise, once again, the recording will be available afterwards. It'll be saved onto the website here. And if there's no other questions, we can sign off. Thank you very much, Brandon, and thank you everyone for attending.
Yes, sir. No problem. Yeah, thank you everybody for attending.
Take care.